Hello everyone, welcome to my Your Programming Club. Today we will be solving another daily Leetcode problem, and the problem's name is given a number of submatrices that sum to the target. So uh, matrix is given to you which is consisting of integer values, and you have to return the number of submatrices of this matrix which result in a particular target. Okay, so for example, if you take this matrix as your input, and your target sum is, let's say, 0, then you can see that these submatrices of this matrix are having target sum as 0. So the number of such submatrices is 4. So your answer will be 4. Okay. So let's have a look at the constraints. The length of the matrix is of order 100, and the width of the matrix, or number of rows and number of columns, are of same order, which is 100, and the elements will be ranging from -1000 to 1000, and the target that we have to search for is ranging from -10 raised to power 8 to 10 raised to power 8. Okay, so in the problem statement also, it is the same thing that I have told you, that you have to find a submatrix which equals to target sum. So let's see how we can do that. In order to achieve this particular aim, what we will be doing is, we will firstly apply brute force approach. In that we will be generating all the pairs, coordinate pairs. Okay, so these two coordinate pairs we will be generating. Okay, this will require us to, even to generate these coordinate pairs, you will require O of n square into m square, where or let's say order of rows square into columns square. Okay, because you will be generating this combination, and then you will be generating this combination. Okay, and in order to generate these two combinations and apply them in combination, okay, in order to get a submatrix, you will be requiring this much number of operations, and number of rows, as it's mentioned in the problem statement constraints, is this much, order of 100. So 100 square into 100 square, which will be nothing but 10 raised to power 4 into 10 raised to power 4, which will be nothing but 10 raised to power 8. Okay, so this much number of operations will be required by your program even to generate a submatrix, let alone doing the sum of that submatrix. If we keep that aside, even for generating a submatrix, coordinates for submatrix, these are coordinates for submatrix. Okay, so this number of operations required and these number of operations are greater than 10 raised to power 8 operations limit. What happens is, if let's say the number of operations required by your program exceeds or become equal to this particular limit, then you may get a TLE and your solution will not be accepted. Okay, so in order to get your solution accepted, you have to optimize this brute force approach. Okay, so for that we will be using a technique. First, let me introduce that technique to you. I will be providing a link for it also, a link of article describing this technique. The technique is prefix sum. It is a separate technique, plus in combination we will be applying hashing. Okay, hashing is nothing but you will be using hash set to find that whether you have seen a particular value before or not. So let's see what prefix sum is. Okay, so I will be providing link for this particular thing, and let's see how we'll be dealing with it. So let's say our input array is given to you. It is 1D only as of now. So if I have to find the prefix sum array of this input array, let's say this is array, and we have to find prefix sum array. Okay, so what you will do, let's mark the indices. If it is the 0th index or it's the very first index, then you will copy the number present at that index as it is. No changes will be there. Then once you are done with it, you will copy the, when you are at an index which is not the first index or the 0th index. Okay, so what you will be doing is, you will be first copying whatever the element was at that index, and you will be adding it to previous value of prefix sum array, which is 2. So it will be nothing but 4. Now similarly here also you will be copying value and now adding this to your copied value, which will be nothing but 6. So your prefix sum array will be looking something like this: 2, 4 and 6. Now let's say if I ask you that how many number of times you are having a sum equal to 4. Okay, so how many times a subarray is there which sums to 4? So how many subarrays are there if you count them? This is one subarray which equals to 4. This is another subarray. Besides that, there is no subarray. Subarray is a contiguous part of array. So there is no subarray that equals to 4. Okay, so now the question arises, how we will be finding that how many subarrays count to 4. So what we will be doing is, for each value generated for the prefix sum at each index, we will be storing them in our hash set. Hash map, sorry. Okay, now you may mark the values. These are prefix sum values, and these are their frequencies. So 2 is occurring once, 4 is occurring also once, and 6 is occurring once. Okay, and before that we will be pushing 4 minus 0 to the hash map, and its frequency will be 1. Okay, now while basically this enqueuing of values will be done as you are making your prefix sum array. What you will be doing is, let's say you are at 4, you will see what is the current value of prefix sum. It is 4. Okay, now let's say values in the hash map are till here. Okay, hash map is filled till here. For this illustration we are not considering values below. Okay, so now let's say prefix sum value is 4 as of now. And what was the target for this particular illustration was 4. Now 4 minus 4, this is the current value of prefix sum. It is minus target, it is nothing but 0. So how many times 0 is occurring? It is occurring only once. So you will say that there is one subarray of sum equal to target. Okay, so let's say you have to count subarrays, or let's say count target array. It will be incremented by 1. Okay, now we came to 4, so 4 will be inserted into your map. Now your map is having values till here, only till 4. Now your current prefix sum value is 6. Now 6 minus target, which is equal to 2. So how many times 2 is occurring? As you can see, 2 is occurring only once. So your current array will be incremented by these number of times. How many number of times? The number of times which two have already occurred. So it have occurred one time only, so you will be adding 1. In total your answer will be 2, and at last you will be enqueuing this 6 to your current hash map state. Okay, so this is how prefix sum is working. And if you derive a general formula for finding prefix sum at a particular index will be nothing but the value of array at that index plus, if it is the index which is equal greater than 0, then you will be adding previous value of prefix sum, which is index minus 1, else you will be giving out 0 only. Okay, so let's say if you are at the very first index, which is the 0th index, then you will give out 0. Okay, so this is a ternary operator that I have used. Okay, this is the formula for prefix sum. So now why we are calculating this prefix sum, that I will be telling you in the implementation part. Now since you were required to use for loops even to generate the coordinates for subarrays, even to generate these two coordinates, you are required for loops. So your loops will be decreased with the help of this prefix sum plus hashing technique. How we will be doing that? Let's say you want to find, let's take a bigger array, or let's take this array only. Okay, so let's check this part. Okay, in this particular part, as you are able to see that this is your left column and this is your right column. Okay, now you have to do summation of whatever is present between these two columns, and your number of rows can vary. So for example, let's say you are considering only one row, only this much part, then it has been converted to 1D array. Okay, let's say how we will be finding range prefix sum between two given ranges. Okay, so let me take this prefix sum array to a separate slide. Okay, so this was your prefix sum array 2 4 6 0 1 2. Now let's say you want to find out what is the prefix sum between these two locations. Sum of subarray starting from, this is your left column as of now, and this is your right column, and you want to find the sum. So what will be the sum? It will be nothing but prefix sum of whatever the value is at prefix sum of right column minus, there are two conditions. Let's say left column minus 1 is greater than minus 1, so it means that you are well within the bounds of indices, valid index. Then it will be nothing but, if your index minus 1 is greater than minus 1, it means that it's a valid index. So you will subtract, in that case you will subtract prefix sum index minus 1, else you will be subtracting 0 from it. Why I am saying so? Because let's say if you remove whatever was the sum in this part from the 6, you will be having only sum of the subarray which is constituting of this part. Okay, so since 6 was the sum of this whole array, okay, 6 was this complete sum. Now from this complete sum, if you are removing from the green part, if you are removing the white part, then you will be getting only blue part. That's what we are doing here. Okay, so one value of index previous than the left column, and if we subtract it from our prefix sum value at right column, then we will be getting sum of subarray between these two columns. Okay, left column and right column. Okay, so this is for this calculation. Now we can from this particular thing we came to know that we can easily find out the sum between left and right column. Now what about these two parts? These two parts will also vary. You can take one row, you can also take two rows, you can also take 3 rows, up to 3 rows, which is maximum number of rows. You can take them between these two columns. Okay, so your values that you will be taking can be something like this. You can either take this much number of rows, or you can take this much number of rows, or if you want you can also take this much number of rows. Okay, these are two fixed left and right columns, and this is the right column. So for left and right column, both of them you will be requiring in total 2 loops, and to vary the number of rows you will be requiring 1 loop. Okay, so and also along with that, with the help of prefix sum and hashing, you will be able to find out all the sums in O of 1 only. Okay, and besides this time complexity, everything will be done in O of 1. So how we will achieve that, I will be explaining it in the coding part. Right now what I can tell you is your time complexity will be columns square into rows. Okay, column square is 10 raised to power 2 square and into 10 raised to power 2, which will be nothing but 10 raised to power 4 plus 10 raised to power 2, which will be 10 raised to power 6. Okay, so all in all, this will be your time complexity, and since it will, this number of operations is lesser than the operation limit, which is 10 raised to power 8, so your solution will be getting accepted. Now let's see the implementation part. I hope I am making sense while explaining prefix sum. Else if you are finding a difficult time to understand, you can surely visit the link that I will be providing you. This is the link that I will be providing you. Okay, you can explore this link and then you will be able to understand how the prefix sum is working. Okay, and this article I will be also providing link for. This is prefix sum on a 2D array. Okay, now coming back to the implementation. This part is just for debugging. If you want, you can print matrix values at different places so that you will be able to understand how this whole prefix sum thing is working. So first of all, in the first step, what we will be doing is we will find prefix sum of each row. Okay, now once we are done with it, we will be moving to the next step, which will be finding prefix sum, matrix sum basically, not prefix sum, of all possible submatrices. Okay, so coming back to our example, let me use it to show you how this thing will work. Let's say it's a 3x3 matrix. Okay, and you have fixed this column as your left column. For now I am writing left only, and this column as your right column. Okay, now let's say you want to vary the number of rows. Okay, so the number of rows, as I mentioned, can be this much or this much, or it can be 3 rows altogether. Okay, so the number of rows will vary. Now you have fixed the left and right columns. Okay, now if let's say I want you to consider it as a single array, how you will be able to consider this as a single array? If let's say your array is starting from here, let's say this is the 0th index and this is the first index and this is the second index. Okay, so your array is standing vertically. Now the technique that I just explained to you, prefix sum plus hashing, this technique can be applied if even if your array was something like this: 2, 2 and 2, 0th index, first index and your second index. Okay, this is the same is the situation here only. Okay, so you will be applying prefix sum plus hashing to find what will be the, so you will be applying prefix sum plus hashing to this particular array which is standing vertically, you can assume. Okay, so it will be nothing but a 1D array. Okay, for this part, for each of the rows you will be finding prefix sum. Okay, by which technique? By this technique, prefix sum, this whole technique, right column minus this is your index is nothing but left column. Okay, so let's see the implementation. There it will be more clear to you. So first of all, we will be for each row, after fixing left and right column, for each row we will find prefix sum between left and right column. Okay, so for the first row you will be finding prefix sum between left and right column. Okay, for the first row prefix sum, then for the second row between left and right column, for the second row between the left and right column. So you will be having a 1D array at last, standing you can assume it vertically. Okay, so then you will be applying hashing also. Okay, so while you are forming your current sum, okay, you will be applying hashing and then seeing whether you have seen current sum minus target. Before that you will be adding 0 to your sum frequency, because adding 0 is helping us to find, let's say your target was 4 and your current prefix sum is also 4, then 4 minus 4 is 0, so you should be having at least one entry for 0. That's why we are adding one entry for 0. Okay, so after that, for each entry of current prefix sum you will be adding one frequency. Okay, so you can change this whole thing to current prefix sum. Okay, and this is just the prefix sum for current row. Okay, prefix sum current row. Okay, and this is your prefix sum, running prefix sum. Okay, and at last you will return your sum count. If you are still having any difficulties or any doubts in understanding this particular problem, you may ask them in the comment section of the video. And thank you for watching. Have a great day ahead.